everybody, in this video we're going to be talking about repeating decimals and how you can convert between fractions and either repeating or terminating decimals. So in a previous video we talked about how you can express fractions as decimals by looking at the prime factorization of the denominator. So 40 can be factored into 8 times 5, and 8 can be factored into 2 times 4, and 4 can be factored into 2 times 2. So the prime factorization of 40 is listed here. And if we want to write a fraction as a decimal, we need to make it so that the denominator is a power of 10. And so we know that 2 times 5 equals 10. So if I want to have more powers of 10 in the denominator, I need to multiply by 2 more 5s so that this 2 and this 2 have 5s that are paired with it. And if I multiply the bottom of the fraction by 2 5s, then I also need to multiply the top of the fraction by the 2 5s to make it an equivalent fraction. And 5 times 5 is 25, and 7 times 25 would be 175. So I'd get 175 over 3 10s multiplied together, which would be 1,000. And that means that my last place value is going to be the thousandths place value, so the third one. And I will have a 5 here, a 7 here, a 1 here, and then 0 wholes. And so this is the decimal that is equal to this fraction 7/40. But there's also another way that you can get this same decimal, and that is to take 7/40 and convert it into a division problem. So if I have 7 wholes and I divide it into 40 groups, that's going to give me 7/40. But if I do long division and I extend my place value system to include decimals, then that will give me the decimal form of this fraction. So to start off, I would say, okay, well, if I have 7 wholes and I divide them up into 40 groups, well, I will have 0 in each group because I don't have enough wholes to put in each group. But if I take those 7 wholes and convert them into tenths and split them up into 10 pieces, then I will have 70 tenths. And with 70 tenths, I'll have enough to put 1/10 in each of my 40 groups. So notice that this decimal is lining up with this decimal because I'm taking each place value and dividing each place value one at a time. So when I put 1/10 into each of my 40 groups, that takes care of 40 of my tenths, so I can subtract them, and I have 30 tenths left. Well, 30 tenths can't be split up into 40 groups, but if I break them up into hundredths, then I'll have 300 hundredths, and 300 hundredths can be split up into 40 groups, and I think I should end up with 7 in each group, because 7 times 40 is 280, which would leave me with 20 hundredths left over. Then I can take each of those hundredths and split them up into thousandths, which means that the 20 hundredths would be 200 thousandths. And if I take 200 thousandths and split them up into 40 groups, that should give me 5 in each group. And since 5 times 40 is 200, that means I have no remainder, and I don't need to add on any more place values after this. Technically, you can add on as many as you need to until you get to a remainder of 0. And notice that this decimal that we got through long division is the same decimal that we got by multiplying the top and bottom of the fraction by numbers that would make it so that you have powers of 10 in the denominator. So in my opinion, the red method is the easiest if you have a denominator that factors into 2s or 5s. But sometimes you'll have fractions where the prime factorization of the denominator does not have 2s or 5s, in which case your decimal is actually going to be a repeating decimal. And the way to see this is by doing the long division process. So if I wanted to change 1/3 into a decimal, I would have 1 whole that I'm dividing into 3 groups. Well, 1 whole can't be split into 3 pieces, so I'll have 0 wholes in my answer. But I could make it into tenths, and I would have 10 tenths. When I divide that into 3 groups, each group gets 3 tenths, which takes away 9 tenths. And I'll have 1/10 left over. That 1/10 can be split up into hundredths, and I would have 10 hundredths, which if I split those into 3 groups, that will give me 3 hundredths in each group. That takes away 9 of the hundredths, and I have 1/100th left over. Then I could move on and do my thousandths, and I could say, okay, well, that 100th can be converted into 10 thousandths. 10 thousandths divided into 3 groups would be 3 thousandths in each group, which takes away 9, and I have 1,000th left over. And as you go through this, you might notice that this same process is just going to happen over and over and over and over again, because the remainder is always 1. And so this decimal is literally going to go on forever. And that tells us that the fraction 1/3 is equal to the decimal 0.3 repeating. And the way we write this is with a bar over the part that repeats. So if I wanted to change 4/7 into a decimal, I could do 4 divided by 7. And this long division is actually a little bit crazy, so I'm going to do this in my calculator. And 4 divided by 7 gives me 0.5714285714285. And that's where my calculator ends. However, this decimal does keep going after this. And if you look at it, there's a pattern here where these 6 numbers are repeated over and over and over and over again. So the way that we would write this is we'd say 4/7 equals 0.571428, and that whole thing repeats. And that's how you would calculate that one. For this last one, if I have 5 divided by 6, I'm going to do the long division for this one. So if I do 5 divided by 6, I have 0 holes in my answer because I don't have enough holes to put 1 in each group. But I can change my 5 holes into 50 tenths, and 50 tenths split up into 6 groups would be 8 tenths in each group, which takes care of 48 tenths, and I have 2 tenths remaining. Then I could take those 2 tenths and I could turn them into hundredths, and I would have 20 hundredths. 20 hundredths divided into 6 groups would be 3 hundredths in each group. 3 times 6 is 18, so I'd have a remainder of 2 hundredths, which I could exchange for 20 thousandths. And so 20 thousandths divided by 6 would be 3 thousandths in each group. 3 times 6 is 18. Subtract that, you get a remainder of 2. You could exchange those for 20 10 thousandths. And again, 3 would go in each group, and that would take care of 18 of them, and you'd have a remainder of 2. So just like when we were dividing 1 divided by 3, notice that this remainder pattern is going to happen over and over and over and over again. And so the way that we would write this one is we would have 0.83, and then the bar would only go over the 3. Because if you put the bar over the 8, like if you had 0.83 like this, what that would mean is you have 0.838383. So pay attention to what the bar is over, because that tells you what part of the decimal is repeating. So this is how you convert fractions into repeating decimals, and most fractions will be repeating decimals because the only fractions that are not repeating decimals are the ones whose denominators factor into either 2s or 5s. But if you have any other prime factorization of your denominator, then your decimal will be a repeating decimal. So to wrap this video up, let's talk about how you make a repeating decimal back into a fraction. So we know that there's some fraction that gave us this repeating decimal, but if we want to figure out what it is, we need to think about what this decimal means. So 0.32 with a bar over 32 means that we have 0.32323232, etc. forever. So since this is the number we're working with, I'm going to call this number x, or you can call it a, or whatever variable you want to call it, but I'm going to call it x. And then what you want to do is you want to find either 10, 100, 1,000, 10,000 copies of x. And the way you decide whether it's 10 or 100 or 1,000 or 10,000 is based on how many places the decimal would need to shift to get to the repeating part again. So in this case, it needs to shift twice. So I'm going to multiply by 100x, because multiplying by 100x will give me 32.323232, etc. And so I have the fact that x equals 0.32323232. And then I know that 100x is 32.323232. And so the reason why we want to have both of these facts is because now I'm going to subtract x from 100x. So I can subtract it as x on the left-hand side, and I'm going to subtract what x is equal to, which is 0.323232, etc. And because both of these decimals go on forever, all of this decimal stuff is going to cancel out because 2 minus 2 will be 0, 3 minus 3 will be 0, 2 minus 2, and so on. And basically, you'll get that 32 equals 99x. And then you can figure out what x is by just dividing both sides by 99, and you get that x equals 32 over 99. Now, sometimes you may need to multiply x in two different ways. Like, for example, if we take the repeating decimal we got on the last slide, which was 0.83 repeating, and we know from the last slide that this equals 5/6. If we were just given that decimal, we would say x equals 0.83333333, and then we would want to say 10x equals 8.33333, and then we would want to say 100x equals 83.33333, and then you would subtract 10x from the 100x. So you'd subtract 10x and subtract 8.33333 because that's what 10x is equal to. And when you subtract all the decimals, 3 minus 3 is 0, 0, 0, 0, and 83 minus 8 would be 75. And so you'd get 75 equals 100x minus 10x is 90x. And if you divide both sides by 90, you get x equals 75 over 90. And then 75 and 90 are both divisible by 5. So if I do 75 divided by 5, that would be 15. 90 divided by 5 is 18. Both of those are divisible by 3. And that would give me 5 over 6, which is the fraction that we found it was equal to on the last slide. So basically the idea is that you just want to multiply whatever x is by whatever you need to make it so that you can subtract it and cancel out all the decimals. So like in this case, we did 100x minus x because that was what canceled out all the decimals. Over here, we did 100x minus 10x because that was what canceled all the decimals out. So that's how you convert repeating decimals into fractions. If you have any questions, let me know.